Okay, guys, let's start. CriblCon. I'm so excited to be here. Especially, this is such a great time to start a presentation, right? Right after the lunch. Yeah, so if I'll see any of you yawning, I'll just assume that you're deeply meditating about what you just heard. Don't worry about it. My name is Przemek Papliński. I am a manager responsible for part of our site reliability engineering team here at Cribl. To be more specific, I'm responsible for observability and reliability team. And I came here all the way from Poland. And I'm also super happy to be here joined by two great engineers, Bill and Kishore. Bill came here all the way from Japan, and Kishore came here from Australia. So, we traveled a lot just to give you this speech today. So I hope you'll find it interesting. But, what are we going to talk about today? I will start with a really, really short introduction to our team, to what we're doing, what our goals are, what's our strategy. And then I will hand it over to Bill that will deep dive in our journey of our migration from self-hosted stream environment to Cribl.Cloud. Because today, everything that we're doing internally in our observability environment is in the cloud. So we'll deep dive into this. And after that, as a follow-up, to be honest, but you will see that this migration to cloud was an essential first step to enable us to use more of Cribl products that are exclusive to Cribl.Cloud, and we'll tell you something about our internal search adoption. This part will be covered by Kishore. So he'll tell you how we moved from Splunk to OpenSearch, and then from OpenSearch to Cribl Search. And at the end, Kishore will also mention something about Terraform Provider. So I promised that I'll start with a little introduction. So our SRE team was founded together with Cribl.Cloud, to be honest, right? When the idea of Cribl.Cloud emerged in the company, first SRE engineer was hired, and this was the beginning. And at the very beginning, we also knew that we will be dealing with a very familiar challenges, familiar for us, because we knew that we'll have to manage massive amounts of data flowing from multiple sources to multiple destinations, all the data in different formats. We knew it's going to be a mess, especially that we also knew that we'll be operating in different cloud providers. We will be also transferring data from some of the hybrid deployments, so we knew it's going to be a challenge. Also, we had some formatting issues that were obvious, and we had multiple. I'm sorry for that. Can you hear me? Yeah. Okay. Hopefully it doesn't happen again. So. Fortunately, we were working in a company that were solving exactly this kind of issues for our customers. That's why we made an immediate and obvious decision to become our first own customer. And we decided to goat food, so to use all of our products as broadly as we can, not only to get the value that is kind of obvious that we're all getting from the products, but also to make sure that we early adopt and we test everything before releasing it to you, so to our customers, right? So right now, today, every single build that we want to release to production is going to our production systems weeks before it's getting released to your environments. And we are also early adopting all the features also in our production systems. So before a new feature to an existing product is released, we are early adopting it. Before a new product is released, we are early adopting it. And what is more, we are even influencing the development cycle of many of our products. And you will hear about it later today when we'll be diving deeper in our journey of adopting our own products. So now let me hand it over to Bill, that will guide you through our journey of our migration from self-hosted stream environment to the cloud. Thank you.
Thank you. Thank you, Przemek. Hey everyone, I'm Bill. In this section, I'm gonna talk about our journey, from on-prem stream cluster to the cloud. let me give you a little bit of like context. So like 4 or 5 years ago, when we started building Cribl.Cloud, we immediately, use our own kind of product. Back then, it was called Logstream, to, collect our logs, metrics, and transform it before we send it to the destinations. So some of you might know, like our cloud organization, the infrastructure, we use Terraform to build those infrastructure. So we took the same file and applied it into a separate AWS account that's used for operations purposes. So it worked great. So in the beginning, until later we introduced search. Some of you know search is a cloud-only feature. So that, and even later that the lake, then what's gonna happen. We started to need to hack our Terraform files, make updates, make exclusions. So this is why the first reason we start to need realize that we need to migrate from on-prem to cloud, because the first reason is to reduce the toys. All those hacks we are doing are pretty hacky. And not only that, because it's a separate managed cluster, we have to do upgrades. We need to manage those resources separately. This was a little bit painful and it's time consuming for us. And secondly, because this cluster was also the largest cluster we have internally, and it's also for the real environment. So it served naturally as a perfect candidate for canaries. Funny thing is, right after we migrate this cluster to the cloud, we found a bug. Fortunately, of course, this is an early build, so the bug was not released to our customers. So, but this shows this is a proof that using this as a canary can really protect bugs or major issues releasing to our customers. And thirdly is a gold footing. Of course, we were already gold footing stream, but migrating to cloud not only allows us to gold footing stream, but also lake search, lakehouse. We are early adopter of lakehouse. So yeah, this allows us to give a timely feedback to all our product teams, because early build means they can see what's there in live like early, so then they can make adjustment to it. And finally, for utilization of all our cloud products, we are heavy user of Search, Lake, and Lakehouse. So this allows us to fully utilize the products, and maybe even few future products to come. So here's some phases, like high-level phases that we do in order to migrate this from on-prem to cloud. Firstly is the preparation, communications, and we also did some experiments to make sure that the cluster can be migrated. Cloud offering has everything we need. And once we verify that, we also figured out, because the cluster was there for several years already, we had to figure out all the permissions. That was also part of the preparations. Yeah, and once we figured it out, then we start spinning the cloud environment. It was pretty easy. You can sign up an organization, immediately you get a workspace. So in our environment, we have one workspace per environment. So we have right now at least 3 environments, not even mentioned like FedRAMP. And once we have this workspace organization, we start updating the permissions. We get metrics logs from different places. We also get logs from like SQS message, S3 bucket. So those permissions now we'll need to allow one this cloud organization. The other is the older legacy self-hosted AWS account, allowing to consume those, because this is related to the fourth phase, that we wanted to run those environments in parallel for a couple of months, to make sure that the cloud organization is working as expected, and also build up the data we have in Lake, because we started to use Lake. We don't want to, just when we switch, we want people that can just immediately search logs in Lake, at least a couple months worth of data there. And finally, once we verify, we switch everything over, we started to scale down this on-prem deployment, and then clean up the resources. Here's the steps, but also the deployment. It looks like how it looks like in our environment. There are a couple of blog posts in Cribl that talk in depth about how we utilize our own product, Stream specifically, or Edge. So I'm not gonna touch that too deep. But so the steps migration is first, of course, the leader. It comes with a workspace when you create one, and then we have lookup and default worker groups. So lookup is the one that we fetch data. You can think of that like a metadata. We fetch those metadata and store it in Redis as a lookup source. So once all the other logs and metrics arrives, we fetch the metadata from Redis and as an enrichment for those logs and metrics before we send it to destination. So this lookup worker group has to be there in the beginning before we migrate anything else. And this also is pretty independent. It doesn't impact the older cluster in any way. So this was easy and then easier and also independent. So this was the first one we moved. And second is the default worker group. Anything doesn't fit really to other worker group, we put it in default. So it's like a massive, a lot of different sources. But it's also, somewhat independent. It doesn't really impact the older. We don't need to switch things. So this is the second one that we switch over. And third is a CloudWatch an Azure worker group that's responsible for receiving, processing all the metrics from CloudWatch and Azure. This requires, like infrastructure change for our organization. So this was the third one we had to pay a little bit more attention to, because once we switch, it takes time to switch it back. So we also did canary first, switch canary organizations to the new leader and start those data flows before we switch the rest. Similarly, tenant worker group is the one that receive metrics logs from all our machines. So it's the biggest worker group, also the heaviest. So we pay very attention to those two worker groups before we switch them over. And yeah, the Edge Fleet, EKS is what we host, those services across tenant, like our portal, API services. It's relatively small compared to other fleets. So it was the first fleet that we switch over. And then we pretty much switch leader, worker, and lakehouse fleets at the same time. Of course, we switch the canary first, and then the rest of the organizations. Once we switch, data will start following to the cloud leader and also the cloud worker group. And at this point, then nothing much are flowing into the on-prem. We will also tackle in the small, leftovers, things like that, but it was not, a major thing. So here are some challenges that we face before, during, and after migration. So firstly is that we had to go back and forth, identifying the correct permissions because it involved in multiple teams. So it was a little bit difficult. The second, during the migration, is we had to keep track because we run two clusters in parallel. The cloud organization. We had to replicate, make sure that the configuration between them, the pipelines are the same. But we also duplicate the data flow to the cloud for Lake. So we also need to be careful not breaking those. That's the major challenge during the migration. And finally, the cleanup, disaster recovery, fire drill, and lastly, like I mentioned, we have several environments. We have to manage them, make sure that they are all in sync. This was also a little painful for us, but fortunately, Terraform is come to a rescue. Kishore will talk about it in a bit. Finally, once we migrate to the cloud, we unlock full portfolio of Cribl.Cloud, not only what we have right now, but also in the future, right? Like insights. And we provide like faster feedback across product team. We have nightly build deployed into this cluster. We can immediately see the results and then see how it's acting in live. So the product team will immediately know where to fix and what's not that usable. And finally, we are also calculating our SLOs using search. And faster iteration means we can detect bugs, issues early. So this delivers a higher quality, better SLO or SLOIs for us. Thank you. So I'll have it back to Shemek to talk about the internal search adoption.
Thank you, Bill.
Thank you.
So that migration didn't only allow us to greatly reduce the operational overhead that we had, because, just between us, we have 5 independent observability clusters. Part of those clusters are our stream deployments, and managing and updating on a monthly cadence those 5 clusters together with all the edge nodes, etc. It took us around 2 weeks every month to go through the whole process. And now this pain is actually gone because we can upgrade all the clusters in just a matter of seconds. But it was also, like Bill mentioned, it was also an essential first step for the further adoption of all the products that we have in our portfolio. And we wanted to adopt search for a very long time. And we decided that we'll do it. But actually the whole journey of our search adoption didn't start with search. It started with our migration from Splunk to OpenSearch. We didn't want to use Splunk anymore. We decided to move out of this platform. And back then, in November 2023, search was not yet ready to take over all the workload that we had in Splunk. And we decided to internally adopt OpenSearch. But after this part, we already knew that having stream in the middle, so having stream in our observability pipeline, makes this kind of migration super easy. And we knew that it allows us to split the further steps, so the future adoption of search, into few steps that we don't have to rush, and we can kind of group the workloads together to also affect the users of our observability platform in the least painful way, right? And OpenSearch kind of set the performance standard. This was the bar we wanted to achieve, because nobody really forced us to internally adopt search. This was our internal initiative, and our first and most important goal was not to affect the users of the platform in any way. So it was unacceptable for us to migrate a data set from OpenSearch then to search in a way that would cause some kind of issues for the users of the platform, right? So that's why we spend a minute on how we want to do it in a way that will be the least painful for the users, and we decided to actually migrate the UI first. So you can use OpenSearch as a data set in Cribl Search, and we did exactly that. So we migrated all the users from OpenSearch dashboards to Cribl Search, and encouraged them to use Cribl Search to search the OpenSearch data sets that we had. So this was the first step. And it was actually very good for us, because from that moment of time, throughout the whole migration, all the users had just one UI they were using in the worst case scenario, they will just changing the name of a data set, right? So it gave us time and it gave us flexibility. But later we had to also have a look at our data sets about the performance requirements that we have from them. Because sometimes we will use our search plugin to Grafana to visualize some of the data that we have in our search data sets in Grafana. And it's unacceptable for us to have to ask our developers to wait, I don't know, a minute for a graph in Grafana to load data, right? It was unacceptable. That's why there were some data sets that we knew we don't have a very high performance requirements from, and there were some that were very demanding, right? That's why we basically split the whole project into the actual migration. We split it into 2 phases. So we split it in, first, we tackled the low-hanging fruits, so things that we simply knew how to do, and we knew that search today was ready to take on those data sets. And the second part was focusing on things that search couldn't at the moment host in a performant enough way, right? So the first part was kind of easy because we could already leverage all the existing search features. We for some data sets we just simply used Lake, and everything was fine. But then we started to think about the phase 2. How do we address those 2 basically remaining performance concerns? One performance concern was related to extremely large data sets, like our data sets where we store our stream logs, basically, from thousands of production organizations, Lake wasn't performant enough. Even if we used S3 or something else as a backend for the data set, it wasn't performant enough. That's why we contacted our development teams, and we figured out that they already started to work on a feature for Lake that will allow us to get more performance. And this feature is called Lakehouse. And we were actually, because we contacted them very early, we were actually part of the development team, working hand on hand together with the development, with our Lake development team on implementing Lakehouse. We built the whole infrastructure for Lakehouse as a team, and we also contributed to the application code. We were also very early adopting, testing, giving constant feedback to the development teams. So thanks to that cooperation, today Lake is what it is. What's more, Lake solved the last remaining issue that we also had with the let's say classical search types of data sets, because Lake resolved our latency issue. And I need to clarify what I mean by latency here. So what I mean by latency is the time between the log is generated and the time it's actually searchable in search, and the developers can search through it, right? We unfortunately found ourselves in a situation when our developers had to wait for 5 minutes between the log was generated to the time they could search it. And some of them actually started to SSH into the EC2 machines and read logs, on a machine, because they wanted to do real-time troubleshooting and not troubleshooting delayed by 5 minutes, right? So we understand this, and fortunately, we were able to address this issue in Lakehouse. So in Lakehouse, we were able to get this number down below 30 seconds. In reality, it's close to 15. And it's enough to encourage our developers to use search for real-time troubleshooting. So I gave you a very high-level overview, and now I will invite here Kishore to deep dive and tell you something more.
Thank you, Shramak. Hi, everyone. This is Kishore. I'm just going to quickly go into some of the challenges that we faced during the internal search adoption project. So, as Shramak mentioned, the data latency in the sense from the time the log is generated to be able to be searchable, it was 5 minutes, but that's unacceptable for us. So, we tried multiple approaches to fix that problem. So all our tenant logs are basically from thousands of cloud organizations are coming to a single S3 bucket, and we use it as a data set in our search to be able to search. But it's not scalable at that point of time. So we used our other projects such as Lake and Lakehouse to solve that problem and get back that latency incomparable with OpenSearch. And the other one is again a poor performance for large data sets. The logs are enormous, and when you are searching for anything over a day or two, it's taking forever. So it's also not acceptable at that point of time. So we again Lakehouse and Lake, all these things help us solve those problems. So other thing is like field acceleration costs. So as the data source is S3, so the number of fields that we add, it generates number of small files as well, which increments the put request to S3, which increases the cost. So that's also not acceptable. So we worked through with our development teams and figured out an efficient way and also improved our cost efficiency. And as Ramek mentioned, one of the things was search was also very new in the product when we were adopting. So any decommissioning of a old product and using a brand new product always isn't easy. It has multiple bugs. So we collaborated with the development team and able to get the timely fixes. All right. So out of all these challenges, if I wanted to pick one particular thing that helped us to decommission OpenSearch and use Cribl Search as our observability platform, it has to be Lake backed by Lakehouse feature. Anyways, so what are the benefits that we see currently with this migration? So we currently see 40% less cost compared to OpenSearch. And our Cribl Search platform is the single observability platform used by all our internal teams. That includes engineering, product, data, and support teams. And we see a number of operational improvements within ourselves, within our observability team. So Bill can feel what I'm saying right now. We have greater control on our observability data where we wanted to send because we use our own product stream. As Bill mentioned a little bit earlier, this serves as the canary, which means it helps us catch issues before our customer catches them. Again, using Cribl Stream helped us to send data to both OpenSearch and Cribl Search at the same time, and allowing our users, which are our developers, to use both of them and try and then help us give feedback as well. So Stream was one of the key factor in successful migration and adoption. In summary, the takeaways from decommissioning OpenSearch and using Cribl Search as our observability platform are, in Cribl, transparency is the core value. So we never backed out to let the development team know how bad the tool was initially. So it helped us build trust between the observability and product development teams. And then we also never backed out to change. We started with S3 as a starting point. So we tried multiple approaches, and then we bring in Lake, and then we bring Lakehouse capability of Lake to solve the underneath problem. So today we have a single observability platform used for all incident management and observability across across the entire organization. And as always, collaboration always wins.
We're almost done. Keep it. But there's one more thing. I just wanted to make sure to mention this from here, from the stage, that for an SRE team, infrastructure as a code, and to be honest, everything as a code is in our DNA. We want to do it. This is how we do work. This is how our work scales. And it was always a very big pain for us that we cannot fully manage, fully configure our products using Terraform, which is our tool for infrastructure as a code. And it was a downwards initiative initiated by us, by our team, to build a Terraform provider for Cribl.Cloud, and is a very unorthodox situation because we have decided to build that Terraform provider on top of our Golang SDK by ourselves. And I would like Kishore to tell you something about it because he was leading the project of developing that Terraform provider. So yeah, thank you.
Thank you, Shramak. Okay, so I'm gonna talk a little bit more on how it started and where we are currently. So currently, so during the process of migrating from OpenSearch to Cribl Search, we had some search log-based alerts in OpenSearch that are created manually, but we don't want to do that manual process in Cribl Search. So we quickly figured out a way to use our own API and integrated that into our CI/CD mechanism. So that helped us to shift left for our developers to have for our product teams to define their own alerts and everything. And at the same time, we got this idea and we collaborated with our product team, brought up this idea, get it prioritized, worked together, and then developed. And we also got footed the Terraform provider in our observability platform. So in our observability platform, we have not just one workspaces, multiple workspaces for different purposes. And the same configuration has to be applied manually, which is a pain. I'm sure most of you understand. So we started using our Terraform provider, which is in preview, as you might have heard yesterday, to build and to use our own Cribl Terraform provider. And we also implemented some reusable modules, not just for our purpose, but also for community purpose. Some of the modules are you can create, you can just copy the JSON of a source or destination or a Cribl Search JSON from UI and then put it in as a file and then use the modules that are in our public repository to manage it via code. So, and you can also do hybrid workers as well. And a note to mention, Terraform provider is only cloud-based. So a cloud org with hybrid workers, it will work, but you need to have a cloud org. Thank you.
So
Thank you.
That's all, and we'll be happy to get any questions.